Okay, we're going to look at a mean value theorem problem. So we have several theorems that have similar sounding names. This one's about mean value theorem. We want to determine whether mean value theorem applies to this function on this interval, and if it does, to find the values of c guaranteed by the theorem. Okay, so two things to check for mean value theorem. The function needs to be continuous on the closed interval a, b. Okay, so here's our function. This function is not continuous for all values of x. We want to think about where that function is continuous. This function is continuous for x greater than 0, or we could write the interval 0 to infinity. And that includes our interval 1 to 3. So we're OK there. So yes. All right, the second thing to check for mean value theorem is to think about whether the function is differentiable on the open interval. On the open interval from a to b. Open interval a to b. Okay, so for this function, let's think about its derivative. Right, so f prime of x will be 1 minus 2 times 1 over x, or 1 minus 2 over x. And that derivative exists on the entire domain of the function when x is greater than 0. So that includes our open interval, 1 to 3. So this is also yes. This is open interval. OK, so the two criteria are met. So our answer would be mean value theorem does apply to the theorem, or to this function on that interval. And if it does, then we want to find the values of c that are guaranteed by the theorem. So the conclusion of mean value theorem says if these two conditions are met, then there is an x equals c such that f prime of c is going to be equal to f of b minus f of a over b minus a. Instantaneous rate of change, or slope of tangent line, is equal to average rate of change, or slope of secant line. And this c value will be between a and b. All right, so we need to find c. So we're going to have our derivative. We found that over here. I'm going to put a c there for my, my unknown here. So 1 minus 2 over c. That's my f prime of c. And that's going to equal f of b minus f of a over b minus a. All right, so here my a and my b are x and y. So I'm just going to make a little chart over here. My a is 1, so f of 1 would be 1 minus 2 ln of 1. Natural log of 1 is 0, so that's just 1. And then my f of b, when I put in 3, I'll have 3 minus 2 ln of 3. And I can't simplify that especially nicely, so I'm just going to leave it like that. OK, so my f of b, that's my f at my right endpoint, is going to be 3 minus 2 ln of 3 minus f of a. That's my output when I put in the left endpoint of the interval, over b minus a, 3 minus 2. 3 minus 1. My right endpoint is 1. Good to catch that mistake before we get too far here. OK, so from there, now it's just a matter of solving this equation. Everyone's a little bit different, so you just have to kind of go through the algebra, take it one step at a time. The first thing I might do is combine some like terms on the numerator and on the denominator over here. 3 minus 1 is 2. And then I might notice that I have a common factor of 2 in the numerator here that I can factor out. And then I can cancel that with the 2. that's on the denominator. So I now have 1 minus 2 over c equals 1 minus ln of 3. I need to solve this for c, but one thing I might notice is that I have a 1 constant on both sides of the equation. So if I just subtract 1 from both sides of the equation, that term goes away, and I'm left with negative 2 over c equals negative ln of 3. Maybe multiply through by negative 1 next. As long as you're following legal rules of algebra here, there are a lot of orders you could do these steps in. All right, so maybe multiply through by negative 1. So let's go over here. I'll have 2 over c equals ln of 3. And then I can do the reciprocal of both sides here, or I could cross multiply and divide, however you want to think about that. But I would get c over 2 equals ln of 3, multiply through by 2, I'll get c equals 2 ln of 3. Okay, so mean value theorem says that that c value should be between your a and your b, between 1 and 3. So I might want to get a decimal approximation for this, which I did over here. 2 over, I did that wrong. Sorry. Okay, so when I take the reciprocal of both sides, I didn't take the reciprocal of the other side here. Okay, so when we take the reciprocal of both sides, we have c over 2 equals 1 over ln 3, reciprocal of both sides here. And then if I just multiply through by 2, I get c equals 2 over ln 3. All right, so mean value theorem says that that value of c should be between 1 and 3. So you might want a decimal approximation for that so that you can see whether it ends up between 1 and 3. So decimal approximation for this, you end up with about 1.82. So yeah, that checks. We're between that interval. All right, so here's our value of c guaranteed by that theorem. All right, so at that point, we've done everything that it asked us to do here. But one important thing, I guess, would also be to make sure that you can make sense of what that means. So we're going to look at a graph of this function on that interval and make sure that we're clear about what all of this means and what the mean value theorem is telling us and what this c represents. So let's look at the graph. All right, so here on this graph, we've got the function that we started with, and I just graphed it on the interval from 1 to 3. On the right-hand side here, we've got a decimal approximation. And what I've got is a secant line on that graph through the points at x equals 1 and x equals 3. All right, so over here you can see the entire function. If I get rid of my restriction, you can see the entire function there. I've got a secant line from x equals 1 to x equals 3. And what the mean value theorem guarantees is that there is a point. We got x equals 2 over ln of 3. So there's a point at x equals 2 over ln of 3 where the slope of the tangent line is the same as the slope of the secant line. So if we look at a graph of that tangent line, there we see that line I just clicked on, that tangent line, and we have the same slope as the slope of the secant line. So that's what mean value theorem says. There is a value in between 1 and 3 where the slope of the tangent line is the same as the slope of the secant line through the points at x equals 1 and x equals 3. So that's what we found, that value c, where that point occurs, where the slope of the tangent line is the same as the slope of the secant line.